the left side are the facts then in this case, and everything that we reason has to come from fact. So what do you think we could come up with? Well, first of all, what do you think? Is this defendant, are they guilty or are they innocent?
Innocent.
So innocent is what we're inclined to think, but the only way we can convince the judge is if we can prove it deductively, meaning we build upon fact to get there. So what could you tell me deductively about this defendant? What are some things looking at that you know? Sure, James? Yeah, it takes 7 hours to get between the two cities. So if it takes 7 hours, unless we fly, okay. What else could we say about this accused person? Sure, Chelsea. Right. So if it would have taken 7 hours to get there and he needed to be at the crime in person, then he couldn't have been the person to do it. So the way we would build this up in like a nice logical pattern is that there were no flights. So we could say, therefore, and I'll show you the abbreviation for that if you're going to be using it. It's these 3 dots like that. Well, you don't put the brackets around it. It would look like, this is what therefore has a symbol in math. Okay, so therefore, the fastest way to Fort Nelson is to drive. And it says, since the accused was in Prince George at 4 p.m., they could not have been in Fort Nelson before 11. So that means, therefore, they couldn't be the person who committed the crime. So when you write up your deductive arguments, you have to basically go from fact to fact. And as long as I can follow your argument and you don't jump over anything, then it's valid. But if you skip over something, like you were to just say, there were no flights, therefore they couldn't have done it. Well, you've missed a huge chunk of information in there, and that's that it takes 7 hours to drive, and driving's the next fastest way. So you have to make sure that you're thorough about it. If you think you've skipped a step, you may end up losing out there. Okay, so we'll take a look at another example. And we just want to think, what could we say about this person? If you have to be at least 16 years old to have a driver's license, what can you conclude if you know Tom has a driver's license? Yeah, Tom is greater than or equal to 16 years old. What if Sue drives a car?
She might be doing illegal actions.
Okay, 1 second. Victor, you want to say it again?
She might be driving a car illegally.
Exactly. So one thing you have to be careful about is, remember, a premise should be a fact. It's not, I don't know, maybe you know someone who's driven without a license, right? Just because you drive a car doesn't mean you have a license. So therefore, we can't conclude anything about Sue. The only information we have is here. That's the only fact we can base our decision on. It doesn't tell us that all people who drive cars have driver's licenses. If it said everyone that drives a car has a license, like maybe one day in the future you'll have to swipe your card and get your retina scan so that they know you're sitting in front of the wheel, and literally the only people who can drive have licenses, but it's not the case right now. So If Sally's 20 years old, what can you conclude about Sally being 20 years old?
It's a possibility, but you don't know. State it.
She's permitted, but we can't conclude whether or not she has one. So again, based on the premise we've been told, we don't know any more information about Sally. Other than their nice names, yeah. What about Bill? If Bill's 12 years old, is there anything we can conclude about Bill?
He doesn't have a driver's license.
Good. So he doesn't have a license then if he's 12. You don't think Bill Clinton was 12 at one time?
William.
Billy? William? Okay.
Billy.
What if Len does not drive a car?
There's nothing. Well, you can have a license, not drive a car.
Good.
It's broken.
Good. So now you're thinking, right? If you have, just because you don't drive a car doesn't mean you don't have a license. I mean, maybe you can't afford the insurance, maybe you can't afford the car, but you could still have a license. So unfortunately, we can't make any conclusions about Len.
That'd be great.
Okay.
I'm down.
So here's, again, let's think logically. All I want you to tell me is, could it be true or not? If it's true, maybe you have a reason you could explain it. If it's not, then maybe you have a counter example that tells me why not. So if two angles are right angles, they are equal.
True.
Yeah, right angle is 90 degrees, so this is the same as saying two angles are 90 degrees. So 90 degrees for both are equal. So we could say that's true. If two angles are equal, they are right angles. Oh, well, what's a counter example?
45.
Yeah, there's many. So basically any pair of angles like 50 degrees and 50 degrees, those are equal but not 90, or not right angles. If two angles are not right angles, they are not equal. Okay, can you give me an example then, a counter example? Okay. So they can be equal even though they're not right angles. If two angles are not equal, they are not both right angles. Okay, let's see here. Two angles are not equal. They can't both be 90 degrees. Okay, yeah, that makes sense. One of them could be, but both of them couldn't. Yeah.
So it is.
Okay, so let's do people need a minute there if you're copying it down? Sure. One more. Maybe I can put, oh, I can't quite put both of them. Okay, so I'm going to show you another strategy for reasoning. This will be just to use a diagram. So assume the following statements are true. All parakeets are birds. All birds are warm-blooded. Polly is a parakeet. What can you deduce about Polly?
He's a warm-blooded bird.
Warm-blooded parakeet bird. Okay. So here's the... So, no, this is just... it's not a bird, no. So
Give it a beak and some feathers.
I'm going to say that this is for parakeets. And then parakeets are only part of a group of things called birds.
Yeah.
Yeah, I know. And birds are part of the group which is warm-blooded. And Polly is here. Polly is a parakeet. So Polly is within the group of parakeets, within the group of birds, and within the warm-blooded group. That's how we know Polly has all of those things applied to it. Or her, I guess, or him. It. What's that? Yeah.
Or it's a parakeet bird.
One thing that, I don't know, you may find this interesting. You might wonder, like, everybody heard of artificial intelligence?
Yes, I hate it.
So, you know what's funny is, it's actually not called, I'm not talking about the movie, but the idea of it. It's funny, it's no longer called artificial intelligence. It's actually called computational intelligence. Any idea why?
No.
Sounds smarter.
Because they compute it.
Well, we're fairly arrogant as humans to assume that we're the only people with genuine intelligence. So I guess we're being politically correct so that we don't offend the machines when they rise up against us. No, anyways, but basically what we're saying is we call it computational intelligence because if we figured out how to do it with them, it's not that theirs is artificial, it would just be different from ours, I guess. But one of the things, the very basic building blocks, if you want to see how a computer can sort of make intelligent, well, semi-intelligent sort of guesses, is you can give a computer facts like a mother is female and a parent. And you can say Sally is a parent and Sally is female. And then the computer can figure out, you didn't tell the computer that Sally is a mother, but based on the rules, the computer knows, oh, female and parent, Sally's a mother. So the computer would be able to figure that out without you telling it the way you and I would do it here. So it's not very impressive, but you can imagine that a computer could do, you could give it like a billion rules to work with and it could do some impressive things. So
Is that how surveys work?
is that how which, sorry?
Surveys?
I don't know what you mean.
Like, you have to answer a whole bunch of questions and then it tells you something in the end.
Oh, I don't know those intelligence survey things.
Oh, well, not really big yet.
I'm not sure that it's the same.
That still sucks though, because
Okay, so here's our premises this time. What can you deduce about Jerry?
all musicians are lazy. That's not even a statement. That's prejudice.
That is prejudice, actually.
Okay.
I hate lazy musicians.
Yeah. Sarah and Paul have it. Yeah, I got this example from a book. I'm not sure that all musicians are lazy. I think you'll find actually that if you're a famous musician, there's no way you could be lazy because it's a lot of work to get famous. But maybe if you just like play rock band in your garage, maybe
Like one of those like trilogy or like tribute bands
Anyways,
that work at like bars.
so if in this case, if you wanted to try it with the diagram, it would look like this. You'd have you'd have lazy people, and unfortunately,
Jerry's there.
you'd have musicians there, and you'd have Jerry. And then it says no student is inside the lazy group, so students would be over here.
Is he a student?
No? Well, who knows?
Good.
Maybe he's studying musician.
So that was what was deduced by Sarah and Paul, is that Jerry's not a student because he's not lazy.
Wait, Jerry is not a student
So-
because he is lazy.
Because Jerry's a musician and musicians are lazy. I don't know, I don't even like the sound of it. I'm going to have to change it for next year. Jerry is not a student. So that means, Jerry is a musician and musicians are lazy. So Jerry couldn't be a student because students aren't lazy.
It's like a riddle. I like this.
I'm student.
It's a riddle, but it's not a riddle.
But again, that's something we can say without, according to the rules we were given, that is a fact.
I like this math. It's like we're like the tech dance, Sherlock Holmes.
All right, let's see what you think of this. All doctors are rich. Geez, I don't know, this person's really digging into musicians. Musicians are temperamental, is that fair?
What does that
They
mean?
really hate musicians.
Well,
Temperamental.
maybe. I'm thinking about people more like, maybe, I don't know, Jack Johnson doesn't strike me as the most temperamental guy.
Wait,
He's got that like mellow surfer thing happening. And maybe like Metallica, maybe those guys are temperamental.
yeah. It just depends on what type of music.
Anyways,
Generalizing it.
so let's get back to our rules here.
Musicians are rich.
So musicians are rich, but no temperamental person is rich.
Okay, I'll let you guys argue it then for a minute, and then we'll see what you came up with. Okay, so what do you think about Gregory then?
He's not temperamental.
Boring.
He's not a musician. Yeah, he's not temperamental either.
And he's rich.
Yeah, you know what? You can come up with a pretty easy counterexample here, because no temperamental person is rich, but musicians are temperamental. That would mean that no musician is rich.
So pretty much he just
But
stated
there's
two
plenty of rich
disses about
musicians. So plenty of poor musicians too, but there's a lot of counterexamples there. So anyways, for the information we were given, here's rich.
Racism.
And out of the rich stuff, doctors are in that group.
And then Greg.
And in there you've got Gregory.
Just put in Greg.
Greg, sure.
He doesn't deserve
G.
Gregory.
Let's just call him G.
Alright, he's
No,
G.
that means he's
He's gangster.
he's
And that
rich,
means he's a musician because gangsters are rappers and they, they're poor.
And then from all the temperamental people,
It hurts hearing that as a musician.
oops. You'd have musicians in
Yeah,
there.
well, wait, I don't get it.
So
If
Gregory,
musicians are not rich, why do rappers just
the
blow money
second
like they
circle
can make
in
it in
there
20
first?
seconds?
Is it supposed to be switched?
so again, I agree with you guys. There are clearly lots of rich musicians, and not all musicians are temperamental. But my point is, we're basing this off the premise that we've been given.
Racist.
And from what we've been given, what we can conclude is Gregory is rich and Gregory is not a musician. Yeah, or temperamental.
Thank you, Logan.
he's a doctor.
Is musician?
We were told he's a doctor, so yeah, for sure.
It just says
Say again.
And Gregory is not.
Are we gonna have to write out a lot of things for this?
Well, there's not a lot of numbers in this one, so yeah, there's more writing.
well, at least you think.
All right. So I'll give you guys a minute in case you're copying down, and then we'll start up again together. Another.
Can we do like 12 more?
I don't know about 12
Damn
more.
it, this has numbers. You said there would be no numbers.
I said there was less numbers.
Ah.
Okay. So here. Oh, you want to do a non-math one first?
Let's get this one over with. Get this one over with.
Okay. So here's what the claim that a person's making is: if you take 3 consecutive numbers, like 1, 2, 3, it's going to be equal to 3 times the middle number. So here's the middle number, times 3 gives me 6. Here's the middle number, times 3 gives me negative 3.
Nice.
So they're trying to say what's the pattern here is the middle number times 3. That's what I get if I add them all up. So how can we prove that this is true? Now, in order to do this, you're going to have to be able to talk with the letters. So your favorite letter that you've used the most is probably X. So let's just say X is the middle number. Then if I've got 3 consecutive numbers and X is the middle, what's the next number after X? So X minus 1 is in there. It's before it.
And then X plus 1.
And the next one's X plus 1.
Aha.
So this is the 3 numbers, right? And if I add them up, X minus 1 plus X plus 1, I'll end up with 3X, which is 3 times the middle number.
That's cool.
So then you can say, yeah, this is true for all integers. Doesn't matter which one you pick, it will always work. And that's how you prove it. This is induction here. You're just showing examples. It's inductive reasoning. You can't always believe what you hear inductively because it's just based on your observations. But deductive reasoning is true all the time. And that's over here. This is deductive. Inductive is based on your observations. That's like the left side. Deductive is based on premises, like the right side. Premise are the things we know are true. I know I took a class in university on logic, and they told me that the sun might not rise tomorrow because the only evidence we have is that our observation has been the sun rises every day. So technically, we can only observe the sun rising, and that's induction. Just like when science does an experiment, they try to generalize their experiment, but their results are still inductive results. So really the only thing that you can prove without it, it's not to say it's not true. It may be true that we hope that's true all the time, that the sun will keep rising, but it's not deductive, so we can't say it's going to be true forever. Right? There may be a time when the sun doesn't rise. Who knows? Maybe the universe just collapses. But with science, anyways, math is the only one that has that luxury of being able to say it's true all the time.
What university did you go to?
SFU.
Nice.
Okay, so these are ones that we talked about. I want to see if you could reproduce them for me. So see if you can do this. Adding two odd integers will be an even number. How do you do that? Okay, well, Kaylee, do you want to say it, or do you want to? Are you sure? I don't want to steal your thunder. Yeah, I said I wanted to hear people see if you could redo it, because I know the algebra is the harder part, but Kaylee had a really good answer. She said an odd number is an even number plus 1. Does everybody agree with that statement?
Yeah.
So when you add two odds, is an even plus an even plus 1 plus 1. So you end up with 2 even and a 2. So yeah, it's another even number. So you've added together 2 even numbers. You'll get an even number out. Okay, let me show you the way that I explained it to you guys. One way we could do this is, here's an even number. It's a multiple of 2. That's a fact. That's the premise, that an even number must be a multiple of 2. So an even number plus 1 is an odd number. We need 2 of these. So there's my odd number 1. Here's my odd number 2. If I add those together, everybody has a 2 in them, so I could rewrite this as x plus y plus 1. And that means the new number has a multiple of 2. Yeah, so it's an even number.
Crazy.
That's so cool. I like that.
All right? So again, see if you can reason it out. This time, do it with the even numbers. 2 even numbers is always even. Okay, let's see. Can anybody throw out an explanation here? 2 even integers? Yeah, let's hear.
Because there's a 2 in every even number.
Yeah.
So if you go 4 plus 2, it's 2 plus 2 plus 2 plus 2 and all that stuff, and then it equals.
So what about if I said 6 plus 2?
That'd be 2 plus 2 plus 2 plus 2.
It still works out to be an 8. Okay, what if I did 8 plus 2? Is that still, that's 10.
Still be even.
Okay, so I'm starting to see now what you're saying. You're always adding up more and more 2s.
There's always be.
There'll always be 2s in there. Yeah, okay, that makes sense. Can somebody give me some algebra that says what, same thing Alex is saying, but with algebra?
Odd number minus 1.
Bracket x plus y. Or that.
So that's 2 even numbers, right? 2x plus 2y. Then the new number, I could write it like this instead, and it has a multiple of 2 in it, so it must be even.
Ta-da!
Ta-da! Yeah. Okay, so if you guys are thinking,
Bill.
Bill, you guys liked Bill, so I'll use it again.
Bill has $12 on umbrella.
There's a wound.
Is it pronounced umbrella?
So let's just say that Bill has an umbrella whenever it rains. Prepared. What else can you tell me about this statement?
He lives in Canada.
Hold on a sec. Yeah, he probably lives in Vancouver, right? France, share with us your... Because it might rain at any time. Okay, so you're on the right track. So France has decided that he's going to have an umbrella with him a lot because it might not be raining.
All the time.
All the time.
It doesn't necessarily mean
What if someone tries to throw up on you?
His head's never wet out of the shower. Okay. Aside from maybe water fights then, and yeah, I don't know. That's good though, right?
Hey.
He'll buy an umbrella if it's going to start to rain. Okay.
he can afford it.
So hold on a second. Let's say this. You are sitting in the calf, and Bill walks by holding an umbrella.
He came from the rain.
Is it raining?
Yeah. But it says whenever it rains. Only when it rains. It doesn't say.
So he might have an umbrella, but it's
Maybe
not
he's
raining.
a vampire and shadows himself.
Okay, good.
Goes to daylight and he just dies.
Pardon me?
Might not use his umbrella.
That's just.
Yeah, okay, but he could still have his umbrella, and it might not be raining, right? Okay, now you're sitting down, and the next day he walks by, he doesn't have an umbrella.
It's not raining.
It's not raining.
Good. So that's the, in logic, we call that the converse. So, or sorry, contrapositive. I'm thinking of the shoes.
What are shoes on
So-
your mind when you're teaching a class?
What's that?
How do you get shoes on your mind when you're teaching a class?
Well, because they're close, right? If it's not raining, then Bill does not have an umbrella. So, oh, come on, it's not English class. But that's another thing that's always true in logic. So, whenever you say like,
Bill not have them.
all right,
Sorry, I'm so slow sleeping.
there,
Guys,
magic. Anyways, so that's another thing you can use as a tool in logic. It's called the contraposition, not the converse. Yeah. But sometimes that's like the way we started out. You're trying to show why something could not be. Like here, you could not be the criminal because you did not have enough time to get there. So sometimes if you're trying to argue, oops, sorry, too far. No, we're not doing those. Sometimes if you're trying to argue, it's helpful to use that as well.